All right, so I figured I'd go through a video as well as the answer key for this review since it was last period before Battle of the Classes. Look at number 1. They want us to use slope-intercept form. So that formula is up here. Yes, you need to have these forms memorized. You have been having them since Algebra 1, so you should know it by now. But basically, all I'm doing, plug in a number for M, plug in a number for B. So look at what they give you. They give me the slope is -7. So that means M is -7. The y-intercept is -9. So B is -9. Therefore, when I plug it into the formula, it's going to be y equals -7 x minus 9. Done. Depending on what they give you, sometimes you're just plugging in points and then you're done. In the next one, the suggestion is use point slope form. Why? Because they give us the points and they give us the slope. So all I have to do, M is still the slope. In this case now, the points are your x1 and your y1, so the 2 being subtracted. Okay? Just like in the alphabet, x comes first before y, right? So in an ordered pair, the x is the first one. Then plug it in. Y minus y1 is -3. And then equals M is -7. X minus x2. So then I can simplify this a little bit further. And that's now why I have y plus 3 equals -7. And then in parentheses, x plus 2. Okay? In the next one, I ask you to use point slope form again because you're given the slope and the point. So do that one and check your answer. Okay, in number 4, they're asking us to do point slope form again, but they only give us the 2 points. So I first need to calculate the slope. The formula for slope is change in y, so that'll be 6 minus 2 on top, over change in x. So because I started with the 6 first, I'll start with the 13 minus 7. So 6 minus 2 is 4. 13 minus 7 is 6. This can reduce, so we should reduce it to 2/3. Then from there, I don't care which point you use. I'll just go ahead and use, since this is my first point, and it's y1 usually, I'll just use that. And then plug in 2/3 for M, x minus 7. So for this one, oops, I went right over my problem there. For this one, you have to do a little bit of work to find the slope first. All right, number 5 is very similar. So try that one, pause it, try it, and then check your answer. After I found the slope here to be 2, I decided to use the first set of points again, the 2 and the 5. Because the other ones were negative, I just figured that would be a little bit easier. I don't have to worry about changing signs. Either one would have been correct. Now we're going to move on to parallel and perpendicular. So parallel means same slope. The equation they give us for the line that they give us already is in slope-intercept form. So the slope of the line is 2. Therefore, the slope of the line parallel is also going to be 2. Okay? They give us the point, 7, 5. So, suggestion, the directions, they use point slope form. Y minus your y1, plug in your slope, and then x minus your x1. Well, my y is 5, my x is 7. So I'm done. Perpendicular means take the slope, which was 2, and do the opposite reciprocal. So it becomes -1/2. Then, again, they give me the point. So 7, 5. It's the exact same point as the other problem, the exact same line. The only difference now is my slope is going to be -1/2. So y minus my y1, which is 5, because remember this is x, this is y. And then my slope, -1/2, and then x minus 7. All right, the next one is perpendicular again. Take the slope, do the opposite reciprocal, so that slope becomes 3. Then it says use point slope, so just plug in your points. Y minus -2 will become a +2. And then my slope is 3. X minus -1 will become +1. So then that one is done as well. I'm not even going to bother boxing it. The next one is parallel. So notice it's not in y-intercept form yet. So I am going to have to take this equation. I'm going to come over here and put it in slope-intercept. So 2y, if I move 3x over, right, then it's going to become negative 3x plus 12. Then I still have to divide everything by 2. So negative 3 halves x plus 6 is the equation of this line in slope-intercept form. All right, so the slope of this line is negative 3 over 2, which means the slope of the line parallel is also negative 3 over 2. If I put this in point slope form, I'm just going to do y minus my y1, right? So it's 6. And then my slope stays the same, negative 3 halves. And then x minus x1, which is negative 2. So really that turns into a plus 2. And I'm done. Okay. Let's look at a couple more parallel perpendicular, but when we use the form y equals mx plus b. Since they want it in slope-intercept form, let's get this in this equation here into slope-intercept form. So you'd have to subtract 3x from both sides, so negative 3x plus 24, and then divide by 2. So then y equals negative 3 halves x plus 12. Okay, the line parallel means same slope. So for slope-intercept, I need a slope and a y-intercept, right? So I know my slope is negative 3 over 2 because it's the same as the one of that line. The y-intercept, they want me to put in negative 2, so that's my b. So all I'm going to do then is y equals, put in 3 halves where the m is, keep the x, and then where the b is, put in a minus 2. And I'm done. So this one was easier because I'm not plugging in a point. They give me the y-intercept, so I'm just plugging it right in. All right. Parallel means same slope. So let's think about what x equals 10 looks like. I like to draw a picture. X equals 10 is going to be all the way off to the right here. It's going to be some vertical line. Okay. So if it's a vertical line, all other vertical lines are going to be parallel to it. That means if it has to go through the point negative 2, 4, it must be a vertical line through the point negative 2, 4, which means the equation of a vertical line is always x equals. Well, where is it hitting the x-axis, or what does x equal in that ordered pair? Negative 2. So the line parallel to it is just negative 2. Okay, let's look at the next one that's perpendicular. This time they give me y equals 5. Do I have that on the next page? No. So y equals 5 would be a horizontal line, 1, 2, 3, 4, 5, through 5. Okay. Every other horizontal line is parallel to that line. They want the one perpendicular, so the one that's going vertical. And it has to go through the point 4, 6. Okay. So if I want the vertical line, it's going to be x equals. And in this case, it's going through the point 4, 6. So what did x equal at that point? 4. And it's the one vertical, so x equals 4. If it wanted the line parallel to y equals 5, then it would just be like y equals 6. It would be going the opposite direction. Okay, so that's parallel and perpendicular. All right, next we have some graphing. This first type we're going to graph using the intercepts. So you just plug in 0 to find the whichever intercept you want, right? So we'll start by doing 4x, put in a 0 for y. Then I just have 4x equals 20, divide by 4, x equals 5. So that means that's the point 5, 0. When when y is 0, x is 5. 1, 2, 3, 4, 5. Okay, let's do the same thing, but put in a 0 for x this time and see what we get for y. So 5y equals 20, divide by 5, y equals 4. So when I put 0 in for x, I got the point 4. So 0, 4, 1, 2, 3, 4. And draw a line connecting those two dots, and you're done. You can always check by putting in slope intercept if you want. So we'll try this one. 12x minus 6, put in a 0 for y, 36. So 12x equals 36, divide by 12, x equals 3. So that's the point. X is 3 when y is 0. So I'm going to go over to 3 and put a dot. All right, let's go the other way. 12 times 0 minus 6, y equals 36. So negative 6y equals 36. Divide by negative 6, y equals negative 6. So that is the point when x is 0, y is negative 6. So I go down 1, 2, 3, 4, 5, 6, and then connect my dots. Okay, that's using the intercepts. All right, then we have linear models, which is the same thing, right? For a linear function, the rate of change and the slope are the same thing. So if it's asking me to sketch, I'm just going to sketch using the y-intercept, so 6. 1, 2, 3, 4, 5. 6 is right here. And then the slope, which is just negative 2, but really that tells me from the starting point, from the initial value, I'm going down 2 and to the right 1. So down 2, right 1. Down 2, right 1. Down 2, right 1. You could also go the other direction, up 2 and then left 1. We'll get the same line. You want at least 3 points. If you do a couple more, that's fine as well. So this one you go up to 4, 1, 2, 3, 4, down 3, over 1. I'll go the other way, 1, 2, 3, and up over 1. So this should look like this one. Okay? So that's what sketching looks like. And then it says find the slope and the rate of change. So these are the same. Slope, rate of change, negative 2. This slope was negative 3, which is also rate of change for both. Okay. Okay. So now verbal description of the linear function. It's telling me the words first. So the rate of change is negative 7. So that just means b equals negative 7. And the initial, m equals negative 7. The initial value is negative 10. So b equals negative 10. This is the same. So now in the function notation, it's just instead of a y, it's an f of x. Instead of an m, it's an a. X is still x. And then instead of, actually it stays b. So the initial value stayed b for both. So I'm just going to rewrite this. F of x equals rate of change was negative 7. And then initial value was 10. That's all it's asking me to do. Okay. The graph of the linear function has slope 4.5 and a y-intercept of 7. So because it says function, I'm just going to use f of x instead of y. Slope is 4.5. So that's still my m value. Whether we say rate of change or slope, it's the same. And then my y-intercept is 7. Okay. So 19. This is a table. So first we need to find the rate of change. So that's just the change in y, right? What is the y going up by or down by, whatever, every time? It's actually going up. So we're going up by 6 on the y. And remember, rate of change, it's a change in y over change in x. So 6 over, what is x going up by? It's going up by 3. So 3. So my rate of change is 2. So that's where I'm making m. All right, and then b says express in function notation. So f of x equals, in for my a, which I made it an m this time, but was a 2, followed by an x. For b, I need to find the initial value. So that's when x is 0. When x is 0, what is y? 19. So then we're done. That's all we have to do. Okay. This one says the graph is given, express f of x in the same form, and then also express it in standard form. So all I'm going to do is put it in y-intercept form and then just move x to the other side. So the initial value, 1, 2, 3, 4, 5, right? And then we go, looks like down 1, right 1 to my next point. Okay, so my slope then, if I'm going down 1, right 1 every time, I'll do f of x is -1, or you can just write negative x. And then that starting point, 1, 2, 3, 4, was 5. So that's in slope intercept form. Okay, standard form would then just be move the x over with the y. So f of x is also y, right? So I'll just move it down here. So y plus x equals 5. Okay, we don't really use standard form much, but your book does, so might as well review it. All right, this one. The y-intercept, 1, 2, 3, 4, 5, 6. It looks like, okay, so we're going to call that -6. And then it's going up, 1, 2, and then right 1. Looks a little bit off, but I'm going to say that's up to right 1. So, slope intercept form, f of x equals, we just said slope was up 2 over 1, so since it's positive, 2x. And then my y-intercept, my starting point, was -6. So that is slope-intercept form. If I want to rewrite it in standard form, I'm just going to move the 2x over. So the f of x becomes a y. And then the -2, when I pull that over, is -6. Okay. I guess it doesn't really matter. Maybe you put the x first, but it doesn't really matter as long as you know they're on the same side. All right, then we got end behavior, and this was the trickiest part. So I'm going to highlight here. As x approaches infinity, that means the right-hand side of your graph. Okay, so that's A says x approaches infinity, and C says as x approaches infinity. So I'm looking at the right-hand side, which is this side, this side, this side, okay? Let me go to my another color. We'll go blue here. As x approaches negative infinity, just means the left-hand side of your graph. Left, left. Okay, so that first part says which side of the graph am I looking at. Then I have to decide this whole your y value, right? Where is it going? So y approaches infinity. That would mean for these two that your arrow is pointing up. Okay? If you say y approaches negative infinity, that would mean the arrow is pointing down. So let's look at this one, because they want me to write the letter, not really write it out. But the left side here, so that's in blue, so it's either B or D, but it's going to negative infinity, right? So which one was that? As x approaches negative infinity, B said it went up, but D says as x approaches negative infinity, y approaches negative infinity. So D is the correct answer for the left side of that graph. And then we look at the right side of that graph, and it's going to negative infinity as well. So I'm looking for as x approaches in positive infinity, it's going down to negative infinity, which is C, because both sides are going down. In 23, both arrows are going up. So I'm looking for both of them to say x approaches, or y approaches positive infinity. So it's going to be A and B. And then 24, the left side, so on the negative side, it's going up. So I'm looking at B here. Left side is going up. And then the right side is going down. So that looks like D. Okay. Then we have ones that we have to write ourselves on the next page. And this is it. Describe the end behavior. So let's, I'll highlight still again. So we had the blue was like the left side, right? The way that I say it though, start by saying f of x or actually they said x first. So as x goes to negative infinity, f of x goes to, so that's on the left-hand side. Which way is this one going? It's going to negative infinity. It's going down. Okay? The other side we had in pink, well, I'll just do purple. That's as x is going to positive infinity. So on the right-hand side, as x goes to positive infinity, f of x is also going to positive infinity because it's going up. All right, this rational function here is a little trickier because let's look what happens as x goes to negative infinity. So on the left-hand side here, as x goes to negative infinity, it's actually not going to continue going up forever to infinity. There's an asymptote here at -4. Okay, so it's going to approach -4 and not go past that. So the way that I write that is I'm going to say, as x goes to negative infinity, my graph, f of x, goes to -4. That's it. It doesn't go any higher than that. Okay? On the right-hand side, so as x goes to positive infinity, my graph is still going to bottom out at -4, right? If you just travel along here, I'm going to the right, to the right, to the right. Oh, look, I'm getting close to -4, but I'm never actually touching it. Okay? And then if you write this function train to the left, it's getting close and never touching it. All right, let's look at one more, and then we'll be done. There is an asymptote here. So what's that look like? -7. I'm going to highlight it so you can see it. Let's start with the left-hand side. As x goes to negative infinity, your graph is going to -7. Because look at it. As I go to the left, right, I'm going. I'm never going to get lower than -7. So that's why it stops at -7. On the right-hand side, so the way I write that is x approaches positive infinity. F of x goes, well, it's going up forever here. So it's going to infinity. Okay? All right. So that should be everything.